This is MP Gunner. It would be more appropriate to call it Sparky, but you know, MP Genius, MP Gold, MP Guarantee. We needed an MPG something, kind of a name, and so MP Gunner, Gunner as in rapid fire. Now what we have is we have a controller. What this controller is going to do is we have an on-off switch. When it's on, we can slow down the spark, and if you look carefully, they're toggling back and forth. And we can speed it up. So under this controller is mounted a power supply. It takes 110, 120 volts AC and converts it into a 13.7 volt DC output. That's typical of an automotive battery. Then we're going to feed two identical ignition coils. And if you watch, we're toggling back and forth so that one coil gets all the energy it needs, and then the system has a chance to recover before the second coil fires. By toggling back and forth, one won't affect the other. Now, currently I have two Napa ignition wires. These are your regular resistor core wires. All the plugs are different, except these two are the same, and these two are the same. Why? Because I want you to be able to see that the output is identical. So any changes we make, you know that this coil and this coil are putting out the same juice. So if you look, the sparks are identical. So we have two identical systems so where we can compare components. Now, the spark plugs themselves. These two are Brisk, brand name, made out of the Czech Republic. Brisk Non-Resistor. Nothing fancy, it's just a normal spark plug, except there's 210 ohms of resistance total. NGK, Autolite, Champion, your typical spark plug companies make what they call non-resistor, but they have about 1,000 ohms of resistance built into them. And the Brisk non-resistor are much lower resistance. This spark plug here is a normal Autolite iridium. So if you get an iridium plug, we can look and see what that looks like. Here we have a platinum Autolite. So these are all the same application. Then we have just an Autolite normal copper core standard spark plug. And then we have two that are labeled PS. These are Pulsar plugs. This is Pulsar iridium, and this is Pulsar natural gas. And when you get on Pulsar's website, the iridium is what they're going to let you buy online. If you want the natural gas plugs, you literally have to call their number and you have to special order them. We'll see if it's actually worth it. And then we have Brisk Silver. This is a non-resistor plug, but it uses the metal, silver, to where this plug has about 6 ohms of resistance from the terminal to the center electrode. And then these outers are like aircraft quality. They're again Brisk Silver, but there is no like outer ground strap. It goes right from the center and jumps across to the ground plane, laterally, sideways. So we just looked at the non-resistor. Let's see how that compares with a standard Autolite resistor plug. So all I did was I moved the wire from this plug to this plug. So let's look at these two. Does anybody see any difference? Which one's better?
I couldn't tell you which one's better, but I can tell you the one closer to me looks like it has brighter sparks.
So the resistor plug might even have a little bit bigger spark than the non-resistor plug. Would you concur?
Yep, that's what I'm saying.
All right. So that does not speak well for a resistor plug. Let's compare the standard to an iridium. Now we've got these two, just Autolite standard and Autolite iridium. Any observations? Feel free to get up and put your nose on there.
I'm just doing something with this on there. Alright, when you turn it up, the far one gets brighter. When it's down, the closer one seems more consistent to me.
Right, so the iridium has a tapered tip, and it's hitting more consistently in one area, which makes it look a lot more consistent spark than your standard spark plug, which is just constantly jumping spark around the edge of the inner electrode towards the outer electrode, so it seems to be moving more.
So the iridium has a very, very fine point on it, and to go from that fine point to the outer, there is only one fine point. Whereas the standard plug has like a disc shape, and the spark may go from here to the outer, or may go from here to the outer, or may go from here to the outer, so you see it jumping around inconsistently. All right, the one big difference between the two is that the iridium will last 200,000 miles and still fire. The standard plug, at about 70 or 80,000 miles, you're going to start getting serious misfires because it is way past its normal lifespan. Now, let's compare iridium and platinum. So we will have the iridium and the platinum plugs firing. See if you notice any difference. I'm sure the camera's not going to pick this up, but if you look at it from this angle, you will see the platinum plug jumping from the ceramic out to the outer electrode. The iridium does not do that, but the platinum plug mostly fires from the tip to the outer electrode, but I'm watching it jump from the ceramic to the outer electrode.
Is that when it sparks?
Folks, platinum is an incredible catalyst. It's used in catalytic converters, it's used in a lot of industrial processes, and it makes the world's worst spark plug. Why was it adopted? Because back in the 1980s, the EPA said that the OEMs had to go, at that time it was 90,000 miles, without doing anything but changing air filter and oil. No tune-ups allowed in the first 90,000, and the car still had to be able to meet emission standards. And based on the technology of the day, somebody came up with this bright idea, well, hey, we'll throw platinum in there, because the platinum plug will last 150, 180,000 miles and still spark. But it has no oomph. It's such an incredible catalyst that it will initiate a spark through pretty much anything, but a very weak spark. The way the coil and the spark plugs work in harmony together is the coil is grounded out on the one side. So you got battery voltage, and then you just pulse the ground long enough to build an inductive charge, and then when you let go, that charge converts from magnetism back into voltage, and it starts climbing. If you watch it on an oscilloscope, as soon as you let go of that ground, the voltage starts going up, up, up. And when the voltage gets high enough to arc across the gap, that's all the higher the voltage is going to go. And from that point on, the coil just dumps the rest of the energy across that gap. And once you bridge that gap, now you've ionized the path, even in plain air. But even more so when you have a fire going on in a process. Those ions of combustion will conduct the electricity. Years and years ago, it was believed that if you wanted to improve combustion through the ignition system, what you had to do is you had to extend the firing line. You know, get that spark going, and then make sure it arcs forever. So a typical firing line is going to be about 1 millisecond. 0.9 to 1.2 at the most, that's your firing line. And the typical requirements to bridge that gap in normal combustion is around 7,000 volts for a normal spark plug, 7 kV. If you have platinum, it's only about 1.5 kV. Iridium is going to be about 2.5 kV. 2.5 thousand volts with the radium, 1.5 thousand volts for platinum, just to bridge that gap, burn a path. But once the path is burned, then the rest of the coil energy just dumps across that path. By extending that firing line, it's like throwing lit matches on a forest fire. It's already burning. And you can extend that firing line on and on and on. But you've already initiated the spark. You've initiated the ionization. What has been realized more recently is that's not going to get you better fuel economy. That's not going to get you more performance at the drag strip. What is get that KV spike up. You want an explosion of energy, not just a doink that burns forever. Let's replace one of these wires here. With a solid core. Again, the ferrite ring goes to the coil.
Okay, why do we have things sticking out of it?
Ooh, very good question. I'll answer it in a little bit.
Okay.
Now we're going to go to the sober aircraft plugs. We have a resistor wire here and a resistor wire here with things hanging off of it that I'll get to in a minute that currently are doing absolutely nothing. They will be, but not currently.
Wait, I thought the red one was a solid.
This is, yeah, non-resistor,
Okay,
solid
you
core.
said resistor twice.
Ooh, my bad, good catch. So resistor, solid core. These are the aircraft sober brisk plugs. And you can see how it jumps from center to outer. Now can you see a difference in the intensity of the spark? From your angle, it's going to be almost impossible, but
Actually,
you should be
from
able
an
to see
angle, I can see it.
plain and clear.
Yeah, it does a lot better with a solid core in this case.
I can see it from here. It's like a little teeny thing versus this big white neon sign, actually.